In part 5 of this lesson, it's another special case. And again, you can always use factoring by grouping. This is known as the difference of two squares. Before we get started, let's see what it looks like to have a difference of two squares. So this is when we're multiplying binomials that have constants that are opposites. So notice in our first example, we have -2 and +2. When we distribute, we get x squared plus 2x minus 2x minus 4. The two middle terms, when we combine, will cancel out and we'll be left with a binomial. Notice that this is a difference of two perfect squares. There is no linear term. This is called the difference of two squares. Here we have 2x plus 3 times 2x minus 3. When we distribute, notice the two middle terms are opposites. When we combine, the linear terms cancel. And what we have left is the difference, subtraction, of two perfect squares. Now there is no such thing as the sum of two squares. The difference of two squares has a quadratic perfect square and a perfect square that's our constant, and there is subtraction between the two, and there's no linear terms. Let's take a look at our first example, and we're going to do it by grouping, and then I'm going to show you a shortcut. We have x squared minus 81. I notice these are two perfect squares and is separated by subtraction. But let's go ahead and do it by grouping. Our a value is 1, our b value is 0, our c value is negative 81. 1 times negative 81 is on top, and then we have 0. So we're trying to decide what two numbers multiply to give me negative 81 and add to give me 0. It has to be 9 and negative 9. When I rewrite this with four terms, I have positive 9x minus 9x minus 81. I have not changed the value of our problem. We're going to group. We're going to factor out a GCF. We have x minus 9 times x plus 9. These are the two factors. Let's do one more, and then I'll show you the shortcut. I have no linear term. I have two perfect squares separated by subtraction. This is called the difference of two squares. A is 1, our b value is 0, we have no linear term, and our c value is negative 196. Now this is very helpful when you have learned your perfect squares, so you should always have memorized your perfect squares. 1 times 196, negative 196, and then we have 0. So I know that 196 is a perfect square, 14 and 14, and we need 1 to be negative. And we're going to rewrite our polynomial with 14x and minus 14x. We're going to group and factor out the GCF. Bring down your subtraction, and we're going to factor out a 14. One factor is x minus 14, and the other is x plus 14. So you can see in the last two examples that our constants are opposite. So if I recognize this as a difference of two squares, I could simply set up my two parentheses for my two binomials, factor your x into x and x, factor your perfect square into 14 and 14. One needs to be minus and one needs to be plus, and it doesn't matter of the order of subtraction and operation here. Here we have 16x squared minus 361. So I know these are perfect squares. I know there's no linear term. And I know this is subtraction. This is the difference of two perfect squares. So I am going to set up my two parentheses for my binomials. This is when you definitely want to know this pattern to see how you can factor this quickly. And notice this is a difference of two squares. I'm going to factor 16x squared into 4x and 4x. I'm going to factor 361 into 19 and 19. One needs to be plus and one needs to be minus. These are the two factors that when multiplied gives me this quadratic binomial. Let's do one more. This is not a difference of two squares because 2 is not a perfect square and neither is 450. But maybe there's a GCF, which there is, and then we may have the difference of two squares. I'm going to factor out a 2. This gives us x squared minus 225. Now, if you were being asked to factor this completely and this is your answer, you would not get full credit because x squared minus 225 is not fully factored. This is a difference of two squares. So I have my GCF, and now I'm going to set up my two parentheses for my two factors. I'm going to factor x squared into x and x. I'm going to factor 225 into 15 and 15. One needs to be addition and one needs to be subtraction. Now, this is your final answer. This quadratic binomial has three factors: 2, x plus 15, and x minus 15.